Good morning. I believe it's morning for all of the participants except for us. Welcome to this Ophir Photonics Group training webinar. My name is Mark Slutsky. Those of you who don't know me, product reviewer and energy measurement solutions here at the Ophir Photonics Group. Here we have that. The subject of today's webinar is StarLab. Some of you have varying degrees of experience working with StarLab. If anybody's some of you on the team, you may have no experience working with StarLab. The purpose of today's webinar is, with a very limited scope, that 45-minute long webinar, to try and do a crash course, I guess we'll call it, in the use of and familiarity with the StarLab software application. I'm putting it in those words because when we do a full-blown training for new staff here at our facility in Jerusalem, we typically allocate about 6 hours to hands-on work, and about 3 hours out of those 6 hours are spent working with StarLab. So clearly, we're limited just how much we can cover. Nevertheless, I will manage to at least walk you through the main features that are typically used by most users. So relatively new. Hopefully, this will help get you up to speed and give you somewhat comfort level in working with Lab. And those of you who are not so new, hopefully it'll be a useful and helpful refresher course. Just before we begin, on a logistical note, as always, please make sure if you have sound input that you are muted. The length of the webinar, as I mentioned, will be approximately 45 minutes. Questions are welcome and even encouraged. If you have any questions, please ask them. Use the chat text box on the right side of your screen. I will admit, don't tell anybody else, that I am cheating a little bit, and I have next to me my colleague Yitzchak, who did much of the testing. So in case I get asked questions that I don't know the answers to, I have an expert sitting right next to me who will quietly whisper the answers into my ear. So hopefully we'll be able to help all of you, whatever your level of comfort with the StarLab application. Ophir, as you know, a range of measurement solutions for laser power and energy, as well as beam position and size, together with the appropriate sensors for standalone meters. I call them standalone because they can work standalone. They also can connect to a PC. The instruments you see here connect to a PC via USB interface. And for PC interfaces, which can only work connected to a PC, the ones you see are all connect to a PC via a USB interface, except for the Quasar, which connects to the PC via a wireless Bluetooth and then USB interface. StarLab USB, for those instruments that are not equipped with a USB interface, the Nova, the Laser Star, or if you choose the Vega Nova 2 to the PC RS-232 ability, then you would not use StarLab. You would use the older StarCom application. Quasar, the Quasar connects to a PC via a Bluetooth connection, assuming that the PC end there is a Bluetooth to a suitable Bluetooth USB adapter, just for the sake of clarity. Okay, in a nutshell, as a sort of content, StarLab enables you to not only measure data, but also display the measured data using a range of various graph types that are available, a range of functions that we're going to look at in addition to just merely taking a reading. StarLab enables the user to connect multiple channels or sensors in parallel and to not only measure with them, but also to log the data from multiple channels and perform various types of analysis on channels simultaneously. It enables communicate with and control an instrument within one's own software external to StarLab, a sort of a remote control suite of functions. We have a very strong tendency in the software to provide as much as possible flexibility to the user to do their work as they see fit and not to limit them in that area. And said all of that, it still remains as powerful as it is, a very easy to use and intuitive software for which one generally does not really need to open the user manual. Today's webinar will almost entirely be live. In other words, I'm about to get out of these PowerPoint slides and we are going to activate StarLab. I have some equipment connected here. Those of you who are joining us now, please make sure, as I said earlier, that you are muted. What I'm now is I'm going to share my desktop, share the screen with you. I should just let you know that when I share screen, I can no longer see the text box. So if you do have questions and you ask them using the text chat box, I ask you to bear with me until we're done with the live part and come back to the slide, and only then will I see your questions. So I hope that'll be okay. So I share my desktop now, and begin. I hope everybody sees clearly. So we will click on the StarLab icon. StarLab 2.40 is the currently available version of StarLab. Downloadable from the website. It comes on a CD with all the instruments that we ship. The front two is the select device window, and we see all available devices. We're going to keep things simple, and we're going to start with one single channel. So select the thermal sensor automatically carries with it a selection of the instrument to which it's connected. We're going to click together. When it's only one channel, it doesn't really matter that there are other options available. Now, here we are in the main measurement screen. We have here on the main measurement screen, first, obviously, we have the numerical readout, and we see the active window, the channel that's currently functioning, in this case, the only channel. And we see that we're connected to a 3AP thermal sensor, and we're reading right now an average power of 1.4 or so milliwatts. Okay, if we needed to, we would adjust the measurement parameters. The measurement parameters here are more or less the same measurement parameters that one would from if one were use Vega or Nova 2 and going into the menu items there. Here we set the scale, the length, we choose things that are available from the sensor, this range, etc. If we were measuring single pulse energy rather than power, here's where we would make that selection. Here we make adjustments in the graphical axis so that we can optimize the graphical display. We can by either moving the sliders around or by manually typing a number in to set the minimum limits of the y-axis. We can the x-axis, which is the time axis. Let's bring it down to 1 minute so that it moves just a little bit faster, so we can get a better feel for what we're at. This has nothing to do with the adjustments that we make to the measurement. This is purely related to the graphical display. That's important to understand the difference here. There are not different types of graphs that are available. What we're looking at right now is line graph. If we click on that black arrow, we see that we have other options available. We can look at this as a bar chart. And again, we can adjust it to get it to be useful. Look at a histogram where the x-axis is the power value and the y-axis is the number of times that value is the value that was measured. And some adjustments that we can, settings that we can choose that are relevant to the histogram. We can pulse chart where the x-axis is running time and we're looking at the last 100 pulses. Or if we, for those users who like to look at an analog needle, we have a virtual analog needle here. If I just move the hand back and forth over the sensor, we can see that it moves. If we select persistence, we can see where that needle has been in the past. We can deselect that now. Let's go to the line graph. If changes in the parameters and we want to save those, we would click on save. Right now, save is not active because we haven't made any adjustments. Save parameter here would be saved in the EEPROM of the sensor itself, so that next time that sensor is connected to any instrument, that will be the setting at which it'll come up. Okay, the statistical information related to the measurement from the time that the measurement began. We have minimum and maximum readings that have been obtained so far during the course of this measurement. We see our average, we see the standard deviation, and the number of times that we've been over range. In this case, that's 0. If I change the range to a range is too low, of course, now we see that we're over, and we start seeing numbers here. Let's add that to auto, and we go back to a correct range, and we may need to make some readjustments in the scaling to be able to see something that's comfortable in camera. We're looking at milliwatts, so we want that to be here to be able to decide what kind of thing we want to use. Point out that this is no different in StarLab than it is in any of the instruments. The specific configuration, the specific functions that are available, and the specific parameters that the user is prompted to choose depend on sensor type. If we're looking at if we're using a pyroelectric sensor here, it would be other parameters available. There'd be energy range. We would be shown the pulse frequency and certain other things that are relevant for that. The definitions are stored in the sensor, and StarLab reads the definitions and automatically knows how to configure the measurement screen in a manner that's appropriate for that sensor. We're using a beam track sensor, and we've had a previous webinar specifically dedicated to beam track sensors. We would have other choices. Not only would the display be different, but we would then be prompted to choose it, from the position and stability screens, etc. The next set of features that I'd like to look at, I just would like to show you a few other items that are up here in the top menu. In advanced functions, there are a few things that are important to be aware of. Zeroing refers to zeroing of the instrument to get rid of any electrical biases that may be built up there. That's discussed briefly in the manual. This is something that we recommend to do periodically. Calc going to open up these windows. I just want to point them out to you. Calculate enables the user to adjust the pre-stored calibration factors in the sensors. I hasten to add, with all due caution, that one must use when making change like that. And I think it's clear. Response refers to the response time and enables the user to make adjustments in the preset response time, the speed up algorithm, with all due caution that must be exercised when making changes like that. Line frequency refers to AC mains frequency. Depending on what country you're in, your AC mains are either at 50 hertz or 60 hertz. In the US, it's 60 hertz. Europe is 50 hertz. You want to make sure you're on the right settings so that you don't get hum or noise coming into the power supply. And so it tells us what sensor we're looking at right now. I'll just, without actually employing any of them, these icons here. Okay, this return us back to the select device screen. This here restart, that restarts the instruments. The display with affecting any measurements or instruments that are in the middle of being used. This is something historical that is actually not relevant anymore. This is trigger configuration. If we're using a pyroelectric sensor and specifically the pulsar instrument, which actually is right now, we were using that together with the pyro sensor. The pulsar makes possible the function of detecting missing pulses. And for that purpose, one needs to configure the trigger setup to look for rising edge, falling edge, etc. Because right now we're actually connected to a thermal sensor that is inactive, as you can see. Others as they become relevant. Let's now look at some of the functions. In many cases, it's a user or an application requires us to not just take reading, but to perform some additional processing on that reading. So we click that little plus and open up the functions window. And now let's walk through the functions that are available here in the order in which they appear. In some cases, it might have a very, for a more technical term, G reading that's a little bit difficult for me focus is on. If I sort of smooth that out so that I can read it, I would, and I can select, for example, 1 second, 3 seconds. If I were to select 3 seconds, then I would see, instead of the instantaneous actual reading, I would see at any given moment the running average reading over the preceding seconds, and so on for 10 seconds and 30 seconds. If I select that, then let's actually do that. Select 3 seconds. As soon as I don't want to do that anymore, I deselect it and I go back to none. If I'm taking measurements and there's an optical offset, let's say background light in the room that for various reasons, I can't maybe turn the light off, but of course I don't want to include it in my readings, what I can do is subtract it from my readings. I block the laser beam so that the sensor sees only the background light. I would click on offset, select that, and from that moment on, any measurements that are taken have automatically subtracted from the value that had been measured at the moment that I clicked selected offset. If I want to change that offset and refresh it to the current value, I just click on it, and the offset value, the reference value, now becomes the current value. As soon as I select it, as you can see, the value, it goes back to where it was. It goes back to absolute readings. This is a very useful function if I need to measure power before and after some optical element. Let's say, for example, a beam splitter. Let's say, for example, I have a beam splitter that splits off 5% and sends that to the sensor. I want to display on my readout not the 5% of the power that's being redirected to the sensor, but the full power before the beam splitter. Meaning that I know the split factor of the splitter, and let's assume that it's 20. It means 5%. I would see here. I will scale factor, and all numbers, all readouts are multiplied by the scale factor. Very simple math, of course, but it enables me to see the power that's coming out of the laser before, in this example, the beam splitter, instead of the power that's actually reaching the sensor. Deselect that, and now we're displaying the power that's actually arriving. In telecom, where we're using fibers, and it's often useful to display power in units of dBm rather than milliwatts, I click and I get the ring in dBm. I do it, and then we go back to milliwatts again. In some cases, we may need to measure again before and after, or before some optical system, and then at various locations within the optical setup. And I'm interested in knowing the ratio of the power at each of those various locations with respect to the reference reading. What we do is we take the reference reading, let's say a series of optical filters, with the power coming out of the laser. We then click normalize, and then when I put that sensor at any location, what I'm actually reading is the ratio of the current power to the reference power. And again, I can refresh that reference power to a current value by clicking on that button over here. Since I'm really doing much with the sensor, most of these numbers that you see are 1.0 something or 0.9 something. If I put my hand momentarily in front of my sensor, you can see that it has the effect. As soon as we like that, we go back to readings. I made to display total power arriving at the sensor, but rather the power density, or the power per unit area. The typical units for that are watts or milliwatts per square centimeter. So we need to know the diameter of the beam. That's how StarLab will then be able to do the calculation and convert power into power density. If instead of a round spot we have a rectangular spot, then instead of being asked for diameter, we're being asked for the two dimensions, the width and the height. As soon as we enter the appropriate numbers there and select density, reading in this case watts per square centimeter. Do you see that? And we again get a reading of total power. Okay, functions window. Let's move on. In many applications, I need to not only take the measurements and maybe perform some functions on those measurements, I may have a need to record a series of measurements for offline analysis afterwards, for example, or even if it's just for record keeping. A series of functions that enable data logging. So if we want the data, here's one, which is the log setup icon. When we click that, we get the log settings window. Default settings up is to log one screen data. And this, as you remember, that means 1 minute's worth of data, and then it'll stop. If we deselect that, we have a few other options that come up. One is to stop after a time period that I can set here. Hours, minutes, seconds. I can go up to, I believe, 500 or 600 hours. I can stop after a specific number of measurements. I choose that option because it's just the fastest for our present purposes. If I open up browse, I can decide where the logged data file is going to be stored on the disk. If I have a particular folder I need to put it in, or also how much available space there is, just as a sanity check in case that's an issue. So select stop after measurements. Let's click on OK. And then to begin the log, we just press on start. And with the progress bar, it shows us how far we are, logging in progress. It tells us the name of the file that's being created. And logging now complete. It tells us that, and that's the name of the file. The logging starts and stops, that it does not affect, of course, the continuation of the measurements. The graph continues to run even after the log has completed. So the logging and the log does not affect the measurement. The measurement, of course, would affect the logging. If I wanted to, I could and open up a notes window, and I can add an annotation to my log file. Experiment number 7, record on September 12th, etc., anything like that. So you should be aware of that. If I look at the log file, there's a few ways I can do that. If I click on the log file location button, that opens up the set of files that are available. I'm not sure, remember the right file name that I just recorded, but that doesn't really matter. Right? The default is it opens it up as a text document. See details of the measurements, the settings, the statistical data is recorded here, and then the series of, in this case, 100 data points, each one the timestamp and the power level that was recorded. Options for viewing logged files. If I go into File, Open, and I go to that file. Open. The default opening is actually not as a text document, but as a graphic file in the same format in which it was recorded. So I can see the graph. I can adjust the fees if I need to for some reason. Okay, so that I can comfortably view what I need to view. I see the statistics. Of course, I can't change the measurements because the measurement has already been done. If I can drag a little bit and zoom in on an area of interest. If I just do the reverse, it goes back to the original. I messed up the scaling a little bit, so we see that very clearly. But if we need to, we get by Xing here, not from here. That'll close down StarLab. Exit from here, and we're back to the main measurement screen. Viewing files. Again, if I go to open, but I say open file as text, I click that and it'll open it up again as a text document. There's another way to do the same thing we did before. Another option that I have here, though, having gone into this open file menu, through open file as text, if I click on it, I see that I have other options of opening it. For example, I can export it to an Excel. I can export it to a map. There's a variety of things that I can do with this file. If I, for example, need to, want to an Excel file with all the calculation that Excel makes available to me. If I did that, I would need to make sure to perform logging into an Excel-friendly format. option preferences, log. Here's Excel-friendly format or standard format. The reason there's a choice is because the resolution of the timestamps depends on this choice. So it's always going to be the same choice. Okay. We can't do it right now, but this icon here, which is right now not active, is upload instrument files. If instead of being connected to a Pulsar, we were connected to a Nova 2, for example, or a Vega, we could load pre-logged files from that instrument and display them here on the StarLab screen and manipulate them as needed. Right now, it's not active because we're connected to an instrument that does not do onboard logging. But that would be the icon to use if we want to upload something from an instrument that has pre-logged files on it. Okay, walk through the main functions I wanted to point out to you that can be done on when measuring with a single channel, a single sensor. Now let's have a look at what we can do with multiple sensors in parallel. So we're going to shut StarLab, and then we're going to reopen it, double-clicking the icon on the StarLab icon. This time, instead of selecting only one of the channels, we're going to, by selecting the instrument, in this case it's a Pulsar, to which we've got two sensors connected. As soon as we select the Pulsar, all instruments connected to it get selected. If all sensors connected to it get selected. If we had multiple instruments, then we could click on that, and that would automatically select anything that's available. Again, we're on together. I'll explain to you momentarily what the difference is between together and separated. Click on together. And now back in our main measurement screen, but we see that we've got two channels and not just one. Okay, so the scaling is about right, so we can actually see both of them. Each sensor, each channel is represented by a different color. Channel A, which happens to be a PD300 UV photodiode sensor, is represented by the blue line, and that's right now the active channel. The blue line is bold. The channel is represented by a red line. That's the thermal sensor that we had before, the 3AP, and that is represented by a red line, or maybe we prefer to call it burgundy, or whatever the right word that color is. And that's also there, but it's not bold. If I change my mind and make that active, then that becomes bold. If for some reason I want to only look at channel B for a moment, I can make it appear so I can focus on what I need to focus on. I can then put it back. Let's bring the time scale again back down, just so that it's a bit more clear. If I pass my hand over the diode, we can see the effect it had. If I pass my hand over the thermal sensor, we can see the effect that had. Notice that both channels are on the same screen. I get those by click split and those into two separate graphs. The two graphs are actually are separated one graph. The axes are the same. Had clicked not together but separate from select channel, then we actually had two independent graphs. We didn't do that, just that you should be aware. And we can change that graph from a graph to a bar chart. We can turn that into a needle. The other one remains. I can the other one into a gram if I prefer. They tell them to merge. They all go back to one or the other. For adjustments I need to do. Now, the things that I may want to do for some reason when with multiple channels, I may need to perform some kind of functions relative to each other. I may need to measure, I may need to display the ratio between the channels, or some other kind of function that's specific to my application. So in addition to the regular functions which we had before, we all call a math channel. So let's close and look at add math channel. Math allows me to set up a function as I see fit between the two, in this case, two existing channels. The default function that comes up is A over B, meaning the ratio between A and B, and that's represented by the green line. It's treated for all intents and purposes as just another Okay, the ratio between A and B. If I pass my hand over the photosensor but not over the thermal, we can see that the ratio between them was affected in a certain way. If I want, I can change that. Instead of A over B, I can turn that into A plus B. And you can already see something has changed. I can make that A minus B, and again, something has changed. It's a little bit harder to see because of the scaling. If I really want to, I can do something even here, and by clicking on F, I can create my own custom function. Let's say minus B plus A to make it interesting. And there we have that. So we have these channels displayed. This is limitless because it's a function, it's a ratio. If I want to, I can log all three of these channels. In fact, let's do that. So log tiny will again stop after 100 measurements, so that it'll reasonably quickly. And okay, we watch progress bar. Sorry, progress moving. We wait until it is complete. Okay, the graph keeps on running. The measurement has not been interrupted. The file is complete. Location. Let's see if I got. So with settings, we see the statistics, channel A and channel B and channel M for math. We see the 100 logged data points, each one with its timestamp and a measured value for channel A, channel B, and channel M, the math channel. So that's a feature there as well. Step out of StarLab, just a few more things I'd like to point out to you. Options, preferences. In the last configuration, what it then does is it remembers the setup of the StarLab windows as they were, and next time I turn StarLab on, it'll automatically go straight into that configuration. In fact, let's do that. Let's click OK. Close Lab and reopen it. It does stop at the select device window. It goes directly to where I told it that I'd like it to keep reference configuration. If this is the type of setup that I use in my work on a regular basis, I can turn that into a default, and I don't have to keep on navigating my way back there every time I turn StarLab on. Other things that one can do here, there's what accomplished in this very short time, but I hope that I've covered most of the salient features, most of the main features that are in typical use, I would say 90-something% of applications that are out there. So let's stop, and there are no questions that have been waiting here for me for the last 20 minutes or so. I mentioned very briefly at the beginning, I'm going to mention it now slightly less briefly. The important feature of StarLab is the Ophir COM object. This replaces what used to be the ActiveX. This, strictly speaking, and I'm not a software expert, strictly speaking, this is not actually part of StarLab software itself, but philosophically, this is what enables user, for example, systems integrators, to be able to communicate with and control an Ophir instrument, StarLab, but not using StarLab, rather from within their own software. Provide for the users to get them started. I'm not going to explain in too detail because I'm not expert on this, and it's not something that we can demonstrate by nature. This is something that's specific to each application. On our website, those of you who need to deal with this and are not familiar, on the website, there's a lot of information. If you go to the StarLab page, there's a section on the COM object and extensive documentation. If you have any particular need to make use of that and after the presentation you have questions, please definitely do get in touch with us. This is something that we get a lot about. Okay, at the very beginning, our goal is to give a quick but reasonably thorough crash course on StarLab. We can't possibly cover everything, but hopefully cover as close to everything as we can get within the scope of what's available. I think we accomplished that. StarLab is a very powerful tool. At the same time, I demonstrated that it's very easy and intuitive to use, and not at all difficult to learn. I'd like to draw your attention to a video that we have, actually a YouTube video. It is posted on the website in the video section, where our CTO, Brian Greenfield, walked through all the main functions and features of the StarLab application. It's approximately 8 minutes long, very clear. I very much encourage you to share that with your customers, with yours, because that's a very quick crash course and also very thorough and very clear. The best way to learn how to use StarLab is StarLab. I think I've demonstrated that it's not difficult to learn. Working with it, try out different things. The learning curve is not terribly long, and since it is a central tool in the of many, if not most, of our customers, it is important that any of us deal with customers have a pretty good level of comfort with the use of StarLab. So I very much encourage you to find, or if necessary, make time. As you saw, it probably won't take much time to just sit and work with the application a little bit and become familiar with it. Questions? You have a few more seconds in which to ask. I hope I didn't speak too fast. Judging by the audience that was on today's webinar, I hope that I was not speaking too fast. That's not always the case. If there are no more questions now, obviously, reach us and ask questions later. I see that I'm comfortably within the time limit that I set for myself, so that's good. Okay, so that's all for today then. Thank you very much for being with us. I really do hope that this was helpful. Have a very nice day.